Good afternoon, and welcome to week 7 of statistics. Last week we were talking about probability and different rules of probability. This week we're going to extend our probability to some sets of probability or sets of data that we know something about. They're common threads that give us some information about their probabilities. We call these random variables. A random variable is simply the occurrences that happen with a particular experiment. For instance, tossing a coin, you get a head or a tail, that's a random variable. You don't know what it is, but every time you get it, you're either going to get a head or a tail. Or you could have red, green, and blue marbles in a jar, and you reach in and you get a red marble or a blue marble or a green marble. That's a random variable. Another random variable is selecting individuals and measuring their height. That would be a random variable. Every time you get a different result depending on the person. So we'll talk about random variables this week, and then a distribution, a probability distribution that goes along with that random variable. What are the probabilities of certain outcomes with that random variable? We have two different kinds of random variables in general. One kind is discrete. Discrete have very specific numbers for answers because the results are counted. For instance, if we were using the random variable of flipping a coin, and I'm going to flip it 10 times, and the random variable would be how many heads did I get flipping a coin 10 times. So that would be an example of a discrete random variable because I'm counting the number of heads. A continuous random variable, now that's another kind, and the results of the experiments in a continuous random variable are measured, not counted. So the example of height, picking a person at random and measuring their height, is a continuous random variable. Well, let's notice the difference. In a discrete random variable, the results are always going to be whole numbers. It's going to be 0 or 1 or 2 or 3 or 4 because we're counting. On the other hand, in a continuous random variable, since we are measuring, we may get any kind of result. 6 feet 4 3/4 inches, or 6 feet 4 and 0.25884 inches. So depending on how carefully we measure, we potentially could get any number as our random variable, of course, within the range of what would be reasonable. So that's the difference between continuous and discrete variables. We're going to also look at the descriptive measures, the mean, the variance, and the standard deviation for these probability distributions. And this week we're going to focus on discrete probability distributions. There are three that we're going to look at. The binomial distribution. The binomial distribution would be one like the flipping the coin. You have two possible outcomes, a heads or a tails. No other alternatives. Another binomial would be you're testing products and they're either a defect or they're not a defect. Two possible outcomes. Another characteristic of the binomial distribution is the probability of each trial. The success is the same. Every time you try the trial, you have the same probability of success. So flipping the coin, it's 50-50 every time you flip it. The next discrete random variable we're going to talk about is the hypergeometric. And the hypergeometric differs from the binomial in that the probabilities change. The probabilities change because we are sampling without replacement. So every time we take a sample, the population drops, and that changes our overall probability. So that's a characteristic of a hypergeometric. And then we also have the Poisson distribution, and the Poisson is a little bit different in that it is counting the number of events that occur in either a time period or some other interval. Another example of an interval would be the number of defects on a board of plywood. And there could be 0 defects, there could be 1, there could be 2, there could be 3, and the interval would be a board of plywood. But it could also be a time interval. How many people show up at an ATM every 10 minutes? There'd be a discrete number of people that show up in that time period. Then also, we'll look at the different probabilities of these discrete probability functions and learn how to calculate those probabilities in Excel. And next week, we'll continue on these a while and then eventually move into the continuous probability distributions in the next chapter. So here we go with week 7, and hope you're enjoying the course. Thank you.